Hello, everyone. This is a recording to review the Unit 4 Portfolio 2, which in itself is a review of the concepts we had learned in Unit 4 in preparation for your test. So hopefully, that again, you have attempted and completed the assignment on your own first before watching this. If you have not, I recommend that you do so. But I'm going to proceed with this lesson to kind of go through what the correct answers are and give any further explanation that maybe you might need. So in this situation here, you're given these lines. You can see that P and Q are not marked with them being parallel. They look parallel, but I don't necessarily know that they are parallel. Whereas the other lines, the lines that are horizontal, they are marked as being parallel. So I can assume the horizontal lines are parallel. Can't necessarily assume that lines P and Q are parallel. What they're doing is making several statements here, and they want you to state the theorem or postulate that we learned about, or and some of these fall under the degree of converse as well, because they themselves are theorems and postulates as well. That would justify the statement being made. So. Um, so for number one, and one of the issues that students often have difficulty with is that they confuse the postulates and theorems with their converses. You have to remember that the corresponding angle postulate knows we already have uh, corresponding angles. The result of that is that those angles would be congruent. Whereas the converse would be that I know I have corresponding angles that are congruent, therefore the lines involved with them that are kind of positioned so that those are corresponding angles. Those lines would be parallel to one another. So for number one, we're being told that angles 1 and 4 are congruent, and we can see their location. Their location with respect to each other, they have nothing to do with the two parallel lines because they basically have the one line marked parallel as its transversal. So I'm not going to be able to say anything about those two horizontal lines, um, which I already know are parallel anyway. But it looks like it's P and Q that they differ on. So the shared transversal and it's P and Q that are the two lines in question here. We're saying they're parallel. Well, 1 and 4 are corresponding angles. So if those corresponding angles are congruent, therefore, yes, by the corresponding angle postulate's converse, we would be able to say that P is parallel to Q. On the other hand, for number 2, when I look at angles 6 and 8, they share transversal Q. So we're not doing anything with a relationship between P and Q. We're looking at the two lines that are associated with it, namely here and here. So with those, we know that those particular angles are alternate interior angles because I could see where they're both they're between the two lines. They're on alternating sides of the transversal, so they're alternate interior angles. And since we know that the two lines are parallel and the result of those being congruent, that's by the alternate interior angle theorem. For the second one, I mean for number 3, this is the measure of angle 7 plus the measure of angle 8 is 180. Well, here's 7, here's 8. The transversal they share again is Q. So it's these two lines here that I'm looking for that we're looking to that define the relationship, and we already know they're parallel. So now the reason why those would be supplementary is that they are same side interior angles for these two parallel lines, and that's by the same side interior angle theorem. Whereas for number 4, angle 5 being congruent to angle 8, again the shared transversal is line Q. And so those being the shared transversal, these two lines that we know that they're parallel, that the transversal passes through, those angles are corresponding angles. So this will just be the corresponding angle postulate, not the converse, because we know the lines are parallel we have a result of these angles being congruent. Number 5, on the other hand, we're being told that angle 2 and angle 4 are congruent. Now we can see that this one line up here, this upper line, one of the two lines that are given to be parallel, is the transversal. So we're not going to be able to say that that line is parallel or to anything. We're looking at P and Q, and when I look at that transversal and these two angles with respect to each other, those would be alternate interior angles. And if they are congruent, P and Q would be parallel by the alternate interior angle theorem converse. Angles 8 and 9, here's 8, here's 9 are being congruent. They share an intersection point. So yeah, they have a shared transversal, but you wouldn't really say it's a transversal because 8 and 9 are at the same intersection. This is an example of vertical angles, and we know that vertical angles are congruent. So it's not one of the new rules that we learned about in this particular unit that makes them congruent. It's by the vertical angle theorem that they're congruent. So the moral of that story is just because we're on a new unit doesn't mean that it's okay to forget the rules from the previous ones. So number 7 and 8 being, number 3 and 8 being congruent. So here's 8 and here's 3. Now you can see the transversal they share is this bottom line. So even though the bottom line is parallel to that top line, it's a transversal here. So I'm not looking to see the relationship. This is not going to be defined by or define any relationship between these two lines. The two lines that it would help define a relationship for are angles or lines P and Q. And I can see that those are corresponding angles. So for those two lines P and Q, they would be parallel by the corresponding angle postulates converse. 6 and 9. Now they both have transversal Q. That transversal does pass through the two lines I already know are parallel. So yes, I can say that these two angles are congruent because they're corresponding angles. And by the corresponding angle postulate, that's how I know they're congruent. And then lastly, we're given that the measure of angle 2 and the measure of angle 6 add up to 180, which means they're supplementary. So those two angles share this top line as a transversal. So it's not going to help me define any relationship between the two horizontal lines. It's going to help me define a relationship between P and Q. When I look at P and Q, these would be same side interior angles. And since they are given to be supplementary, then by the same side interior angle converse, that would make P parallel to Q. So you have to make sure you have the rules straight between the theorems and postulates and the converses. Again, the basic theorems and postulates already know that we have parallel lines, and then we're able to establish angles being congruent or supplementary depending on which one you're using and which angles you're talking about as a result. Whereas the converses are taking the fact that we know that certain angles are congruent or certain pairs of angles are supplementary, and as a result of that, the lines involved with them are parallel. So you have to make sure you have those straight because you can't state one in place of the other. That's another reason why that I often suggest that students sometimes just state what the rule is rather than state its name, because if you state the name, you might have the right idea. For instance, it may involve corresponding angles. But is it the postulate or its converse that you're using in that instance? But if you make the statement, oh, these two lines are parallel because their corresponding angles are congruent, you're basically stating the converse, and you're not necessarily mixing them up between that and the postulate itself. So we're given that same figure above, and we're told that P is parallel to Q. So in this instance here, we can, draw an indicator or two saying, okay, we know these are parallel as well. we're told that angle 3 and angle 7 are supplementary. Well, we're looking to prove that that's the case. So these are things we have to determine. Let me put them in a different color. It's not given information. The only given information we have is that those are parallel to each other. Okay, P and Q. And we also know that these two are parallel as well, because that was also given by the way that the figure was drawn. So we basically have two sets of parallel lines intersecting each other here. So we want to be able to show that angle 3 and angle 7 are supplementary, or that they would total 180 degrees. There are different approaches that I can take for this. For instance, I mean, one way I could show is that, like I say, okay, well, I know now the thing is they don't share any transversals, these two things. So I can't use any of the theorems or postulates or converses or anything of that nature directly because they don't share a transversal. Okay, angle 3 has P as a transversal, angle 7 has Q as a transversal. So I'm not going to be able to apply those rules directly. Now what I can do is say, okay, well, I know that with the given information, I could say, one way I could go is say, well, angle 2 is congruent, or sorry, take that back. Angle 2 and angle 3 are supplementary. And I know that's the case by the same side interior angle theorem. Okay. I know that angle 2 is congruent to angle 7. That's because they are corresponding angles with this top line being a transversal and P and Q being the lines that transversal intersects. So I could say that that's true by the corresponding angle postulate. With that being the case now, I can now say, well, since angle 2 and angle 7 are congruent, then basically the measurement of angle 7 can replace angle 2. So I could basically say angle 7 and angle 3 are supplementary by substitution. Okay, so I could do that because supplementary deals with just measurements. I'm not saying they're a linear pair or anything like that, but but there's different routes I could have taken for a number of these. I could have involved angle 8, for instance, and kind of done the same thing. Okay, say that angles 7 and 8 are supplementary, angles 3 and 8 are congruent, and kind of go that route. So there's different routes you could take. As a matter of fact, I don't know if I do have a typed out paragraph proof here. Just waiting I'm stalling a little bit so you have time to see this or pause it if you want to see what these things say. But I also have a paragraph proof. And I did go a different route here. I said by the corresponding angle postulate, angle 3 is congruent to angle 8 because 7 and 8 are the same side interior angles for this set of horizontal parallel lines. They are supplementary by the same side interior angle theorem. That means that angle 3 and 7 are supplementary because congruent angles are supplementary to the same angle. And so, I mean, and basically that theorem is based off of substitution as well. So there's different things that you can explain. There's different routes you can take to many of these. So that's why it's important for you to explain yourself, because there's often more than one way to get there. So you have to make sure you're not concluding anything that you can't conclude. So in a very similar instance here, we're told that we know that angle 3 and angle 5 are congruent. We want to be able to prove that P is parallel to Q. Now, again, I mean, we've had several problems prior to this that we said P is parallel to Q, but that's because we had other circumstances that let us prove that, or we were told to assume that initially. Here we don't know that, okay? Well, we know that these two angles are congruent. Now, again, they're at different intersections. They don't share any transversal, so none of the rules that we have in this unit directly apply to this, okay? So I have to basically get to a point where I could apply some of those rules to show that P is parallel to Q. And it doesn't matter which rule, I mean, which route I go, because I could probably go a route where I could use any one of the converses that we learned about in this unit to prove that P is parallel to Q. So here's the method that I'm going to go with. Excuse me. Trying to say here. Okay. So one route I'm going to go here is I'm going to say, okay, well, since I know that these two lines are parallel, I can say that, well, there's one that's more easily done than another one, but okay. Well, here's what I'm stating here, and I'll read off the proof I have. I was trying to see if I could think of another route to get there, but we're given angle 3 is congruent to angle 5. Now we know that these are corresponding angles, angles 5 and 8 for those two parallel lines. Therefore, they have to be congruent by the corresponding angle postulate. We now know by the transitive property, or you could even say substitution, that angle 3 and 8 are congruent to each other. Angles 3 and 8 are corresponding angles when I have this bottom line as a transversal that's intersecting P and Q. So at that point, those two angles do share a transversal. They are corresponding angles, and by the corresponding angle postulate's converse, P would be parallel to Q by a result of that. So is that the only way you could have done? No. But just, I would have students would say that somehow that, these two angles are corresponding angles, and really they're not. They're corresponding angles have to share a transversal. All the angles we talked about in this unit have to share a transversal. If they don't share a transversal, then they are not one of those angle pairings. So be very careful about that, because I'll have students who will claim angle pairings that aren't actually established yet. So the last of these questions, and I believe this is like one of the last slides here, is that you're given a triangle with angles 1, 2, and 3 as interior angles. Angle 4 is an exterior angle with remote interior angles 2 and 3. They want you to find the missing angle measures. Well, the fact of the matter is, I've had students do questions like this, and they have made big mistakes with them only because of the fact that they chose to try to do it without drawing a picture. Because this triangle that's being described is very specific about like kind of the placement of where the angles should be. I mean, really the only possible difference when I draw the figure about to see here is where I could have possibly the locations of angle 2 and 3, they could be reversed. But essentially, if I have a triangle with angles 1, 2, and 3 in the interior, and angle 4 being an exterior angle, with angles 2 and 3 being remote interior angles, it has to look something like this. As I said, you see 3 and 2 here, they could be switched, but otherwise, the relative position of where angle 1 and 4 are, they have to be, basically a linear pair with each other. And that's an important thing to know. Because we could use rules for linear pairs. We could use rules for exterior angles. We could use rules for the sum of the interior angles of a triangle, which we've shown is 180 degrees. So those are the rules we're going to be looking to use here. So for number 12, we were told that the measurement of angle 2 is 50. Sorry about that. Give me a second here. And at the measure of angle 3, one second here. Sorry. And the measure of angle 3 is 80. That's going to help us figure out some other things because, I could find the measure of angle 1, for instance, by saying, okay, well, that and those two other angle sets should have the 180. I could find angle 4 right away because I said, well, I know that the remote interior angle should add up to be what angle 4 is. Or I could say, once I find angle 1, say, well, it's a linear pair with angle 4, so I could do it that way. So what you see here, I actually did angle 4 first because I said, well, it's the sum of these two angles here and here. So I had them get 130. And if I know that this is 130, and I know that these two are a linear pair, that means that this angle here would have to be 50 as well. But I could have also used the fact that the sum of the three angles could total 180, and the only way for that to happen is for that angle to be 50 degrees as well. So the next one, I'm given that this is 100 degrees, and that this is 50 degrees. Again, different ways of doing it. Let me show you how I did it here. I said that the measure of angle 3 should have to be 100 because I know that this here should be angle 3 plus this 50-degree angle by the exterior angle theorem. So 50 plus angle 3 should be 100, so I know that that has to be 50. And again, since this is a linear pair, this has to be 80. And then lastly, we're told the measure of angle 1 is 75. We're told the measure of angle 3 is 20. Well, they circle them, so I'm not saying it's 125 and 202 or something like that. So again, there could be some slight variations to this, but I chose to say, well, the measure of angle 2 should be 180 minus the sum of these two other angles. Okay, these two total 95. And I had this mislabeled. Actually, this is 20. So these total 95. So if I take 95 away from the total of 180, which should be inside the triangle, then I know this is 85. And then the measure of angle 4, since I know that this is now 85 and I know this is 20, I just add those together and I get the 105. As I said, there's different ways. I could use linear pairs. I could use the sum of remote interior angles for the exterior angle. I could use the sum of the three angles of a triangle 180 degrees. All those ideas could play a different role depending on which route you take with these. So, but those are the rules you should be using to find the measurements of these any missing angles like this. But it all comes from first drawing that picture and drawing it accurately. So that's all I have for this, and if you have any additional questions, please make sure to contact me. But until I either get to talk to you on the phone or I see you in a live lesson of mine, I will see you around. Have a good day.